that? 3.8372. Get that? Now, if you press the math key, you can get the cubed root, and you crank that out. Make sure you divide by 4 pi, or you put 4 pi in parentheses in order to get that. It's essential. On the AP test, you will have to make sure that you know how to accurately calculate values like this. Okay? So, let's move on. All right, what am I going to do with that? Go to the table. So we're going to make our table. Here we go. We have R and we have A prime. Okay. Now, by the way, this is a critical number here. What's also a critical number? What's a critical value for this equation? 0. 0 is a critical value because it makes this one undefined. Okay? Now, for the sake of argument, what would your cylinder look like if the radius were 0? It wouldn't exist, right? We'd have a problem with that. So remember we say if something special is going to happen, it's going to happen at a critical value. Well, sure enough, something special happens when the radius is 0. You don't have a volume. Okay, so that's a goofy thing. So I'm going to ignore that one, and we're only going to put in here our cubed root of 710 over 4 pi. And that gives us A prime is 0. All right, now, we have to test to the left and to the right of it. This gives us power because we've got some idea of what to use. Okay? I'm going to pick a value of 1 and 100. Okay? Rather than 1 and like 4, I'm going to show you why. Let's go back to this guy right here. If you plug in a radius of 1, is your answer positive or negative? Positive or negative? Negative. Do you see how you get the negative 710 over 1? That definitely overpowers this guy. So that's a negative. Okay. The reason why I picked 100, I picked an extreme value, because what happens if I plug in 100 in here? It's going to be positive, because now this one's got all the power. This one gets close to 0, so this is positive. Now remember, there's no other critical values out there. We found them all. Okay. All right, A prime is negative to the left of the cubed root of 710 over 4 pi. What does that mean?
Decreasing.
The area is decreasing. Okay, since A prime is negative, the area is decreasing. We're getting lower and lower and lower. And then, to the right of the cubed root of 710 over 4 pi, it is increasing. That is, A prime is positive, therefore the area is increasing. So we can wrap this up. We can say, therefore, a minimum exists, occurs at x equals, I should say r equals, the cubed root of 710 over 4 pi. Because, we just watched Wizard of Oz. You know what I was thinking of. Because. All right. You could write a calculus on for that. Because A prime changes from negative to positive. This is your justification on the AP exam. This is exactly what they'll be looking for. And that's why you had to do that on your quiz. All right, now, final step in the problem in the phase is to answer the question. So, answer the question. answer to this problem? What is the answer to this problem? We did all of this math. Look at all this math. Okay, what's the answer? Okay. Read the problem.
Well, that's the radius you also have to find the height.
Exactly. So we need the dimensions, right, of the can? So we're going to have a radius of, we'll use 3.8372. What's my units? Centimeters, okay? It's a length, centimeters. And then the height equals what?
355 over pi r squared.
Remember that puppy? Okay, we said that we solved the volume here for h, 355 divided by pi r squared, that gives you the height. Now I'm going to show you a little trick, and I want you to do this with me. This is huge. Okay, so on your calculator, get your calculator out, and I want you to compute the R value again. We haven't already done it. It's not on your calculator right there. I want you to redo it. Okay. See this? Cube root of 710 over 4 pi. Everybody do this. I'm going to teach you a trick. It's really, really helpful in doing these problems. Okay, so you have that value. What do we want to do with it? We want to punch it in that formula. Okay, but do you see how it's a little bit complicated? We got something inside of something. So what we're going to do is we're going to store this number in a variable. Okay, if you're familiar with this, you know how powerful this is. Press the STO button. It's right above the on key. And you get a little arrow. It says take the answer and store it in a variable. Now since this is the radius, I'm going to store it in R. So we press alpha R. And then the same answer comes up. The reason why this is really, really cool is because watch, I can clear this thing out and I say, all right, I forgot what R was. Oops, not M. Alpha R. Oh yeah, R was that. It remembers what it was because we're storing it. Okay, we use variables all the time in math, but in the computers, we can actually give it a value and it can remember it. Very, very cool. The reason why it's also cool is we can do things like this. Oh, what's R squared? R squared. Well, R squared is that. Okay. So on our problem, I want to take 355 and divide it by parentheses pi. Oops. Pi. I always like using the times. R squared. See that? And I got 7.644. Again, we're going to use 4 decimal places. 7.6744 centimeters. Those are the dimensions that's going to give you the best. Were you able to do this using the variable? We're going to use this more and more and more as the year goes on. So, got that. All right. Well, the question is, what are the dimensions of this guy? Or can anybody recognize something interesting about this?